Let's go to page 941 and start with 1A. So this one you using the graph to find the limit. So for I, you're looking for the limit of f of x as x approach to infinity. So if you look at this graph over here, as it approach infinity, the y approach is -1. Okay, so your limit would be -1. You can just look at this graph right over here. Okay, so this one would be equal to -1. Now for the second part, for the double I, you're looking for the limit of f of x as x approach to -infinity. So as it goes toward -infinity over here, so you can see that y will approach to 2. So this will equal to 2. And that's it. Okay, now for part B, you're looking for horizontal asymptote. So for I, the horizontal asymptote would be, again, look at the graph, so it's going to be the same. Okay, so horizontal asymptote and the limit to infinity are the same. So you're going to get y equal to -1. And horizontal asymptote for second part as approach -infinity will be y equal to 2. Now let's go to number 3. You're looking for limit of 6 over x as x approach to infinity. So you can just apply what you learned from the horizontal asymptote. Okay, so when x becomes infinity, you're going to have 6 over infinity, so this will give you 0. Okay. Now again, if you remember from your horizontal asymptote, when the exponent of the variable on the bottom is bigger, you're going to get y equal to 0. Okay, number 5, the limit of 2x plus 1 over 5x minus 1, and as x approach infinity. Again, when x approach infinity, you're looking at a horizontal asymptote, so you don't have to worry about the lower term. All you have to do is worry about the higher term. And again, you got 2x over 5x, the x will cancel out, so you will approach 2 over 5. Okay. So again, when the variable have the same exponents, you just look at the coefficient, so it will be 2 over 5. Number 7, you have the limit of x approach to -infinity, and you have 4x squared plus 1 over 2 plus 3x squared. Again, all you have to do is look at the highest degree term. So you got 4x squared over 3x squared. Since they have the same exponent, so all you have to look at coefficient, so it will be just 4 over 3. And because when the x approach infinity or -infinity, all the lower term become insignificant. Okay, let's go to number 9. Looking for limit of 8t cubed plus t over 2t minus 1 times 2t squared plus 1, and this is when t approaches to infinity. So again, when they approach infinity, all you have to do is look at the highest degree term. So if you look at highest degree, this is 8t to the 3. This one, when you multiply, you're going to get 4t3. So basically what you have is you got 8t3 over 4t3. Okay? So this will cancel, so ends would be equal to 8 over 4, so this will equal to 2. Okay, let's go to number 11. You have limit of x over 4 over 1 minus x squared plus x over 3, and x approach infinity. So when the exponent for the top is bigger than the exponent on the bottom, this one will not have a horizontal asymptote. What you have is slant asymptote. Okay, but again, remember limit is same as the horizontal asymptote. Since this one does not have a horizontal asymptote, therefore this one does not exist. The limit, it will just go, it's going to get bigger and bigger, so it does not have a limit. Okay, so the limit does not exist. Let's go to number 13. You have the limit of x minus 1 over x plus 1 plus 6, and as x approach to negative infinity. So this one has two parts. So you just look at the first part over here. Okay, so this part, again, they have the same exponent, both are exponent of 1, so this one will equal to 1. Okay, so when they approach negative infinity, this part is going to give you 1, and this part will just 6. Okay? And so this will equal to 7. Okay, let's go to number 15. Okay, this one it asks you to use a table of values to estimate the limits. Okay, so it's going to approach to negative infinity. So what you want to do is go and make the table. So you have the x, and you have the f of x. And since you want to go to infinity, okay, you want to approach infinity, so you might want to try 1 and 10 and maybe like 100. Okay, so you need a good calculator. So I'm going to use a lot of parentheses, so I'm going to get 1 squared plus 4 times 1, closing parentheses, divided by parentheses. So make sure you have parentheses for the top and for the bottom. Okay, go back, forgot the square root. Okay, so parentheses 1 squared plus 4 times 1, closing parentheses, equal, and take the square root, divided by the bottom, the square root. The bottom is 4 times 1 plus 1, closing parentheses, equal. So this gives you 0.4472. So you want to probably get like a 4 decimal places should be fine. Okay, so you do the same for 10. So again, use a lot of parentheses. So 10 squared plus 4 times 10, closing parentheses. Make sure you push equal and take the square root, divided by, I can use parentheses, 4 times 10 plus 1, closing parentheses, equal. So you're going to get 0.2886. So I'm not going to try 100. So you can use parentheses. Okay, so you got 100 squared plus 4 times 100, closing parentheses, take the square root, divided by parentheses 4 times 100 plus 1, closing parentheses, equal. Okay. So you're going to get 0.2543. Okay, I'm going to, so instead of going 1, 10, 100, you can try 100, and then you can try like a really big number, like, you know, like 10,000, okay, for example. Or you can even try even big number, okay, because this, okay, this one, you need to go and use negative, it approach negative infinity. Sorry about that. So all this would be negative, okay? So watch for that. It's negative infinity, so you have to use negative. Okay, so let's try the big number, like I'm going to try like a million. Okay, and see what happens. Okay, so you can parentheses 1 million. Okay, negative, and you're going to square that plus 4 times 1 million, closing parentheses, equal, take the square root, I'm going to divide it by the bottom, so 4 times 1 million plus 1, closing parentheses, equal, okay, so 0.250000. So you can see it's going to equal to it's going to be 0.25 or 1/4. Okay, so the answer is 0.25. You also can get it from here, negative. Watch, it's negative. Okay, so watch out for the sign. It's going to be negative. You also can get it from here. See, because this is same as if you look at just the top one. Now, when you have square root of the x squared, we give you absolute value of x. Okay, so this will give you that, and on the bottom, this will give you 4x. So you can see that this is going to equal and approach to negative infinity. So this will equal to negative. So this is going to be negative infinity will cancel. So give you negative 1/4, and which match with these. Okay. Okay, let's go to number 17. You're looking for the limit of x to the 5 over e to the x as x approach to infinity. So you can make a table. So you got x, f of x, and then so you can, again, because approaching infinity, you want to make a big number, so maybe like 100. Again, I'm going to use like 1 million. Okay, because you just want to get some kind of comparison. Okay, so you got 100 to the 5 power divided by e to the 5, e to the 100. Okay, so you're going to get 100 second equal. So you can see that this is going to be like super small already. You're going to get 3.72 times 10 to the negative 34. So basically it's going to approach to 0. Okay. Okay, so let's try this one. So 1 million to the 5 power divided by 1 million second e. Oh, it's too big, so you can't even get that. So again, because this is so small, the answer will be just 0. Okay. And you can see that because when the variable is in the exponent, this is going to go faster than that. So number is going to get smaller and smaller and smaller. So eventually it approaches to 0.